Hello everyone. So my name is Junichi Monma, so head of Android Partner Engineering in Japan. So today I wanted to introduce the robot, and so that is tightly integrated with the Android. So and also the Google Play and the Google Mobile services, and also introduced another new SDK that is enabling to the developer to making the application. So supporting to that these systems and also that Android. So welcome to the paper to joining to that Android family today. So Lauren from the SoftBank Robotics. So he will be explain more detail about the SDK today, and also live programming for that paper for you guys. And then paper, of course, assist to the Lauren in this session. So Lauren, please come in.
Thank you. Hello, everyone. I'm Laurent, software director at SoftBank Robotics, and I'm very thrilled to be here today at I/O. And we even brought some company, as I know some of you have noticed earlier. So this is Pepper. He's a humanoid robot designed by SoftBank Robotics, and he's one of the first mass-produced robots to serve as an emotional companion. And the good news is it's coming to the US this year. So we are happy to start supporting the developer community. But maybe we can let him explain more about himself.
Hi there, everybody. I'm Pepper. It's an honor to be here as a speaker at Google I/O. We have a great show for you. I hope you're excited. Are you guys ready? Okay guys, take a break. I'll take things from here.
So this was a short dance to introduce you to the capabilities of Pepper, and hopefully to get you more excited about what we have to share today. So for the past couple of months, we have been working on an Android SDK for Pepper. This is not the first SDK we write, because we've been working on robots for more than 10 years now. But we thought and we wondered, what would be the best robotics SDK? What would make robots as accessible as any other devices, such as tablets and smartphones? And basically, today we want to share our conclusions about this, and we want to show you how simple robotics development can be for anybody. So as you may have already guessed, our SDK for Pepper is an Android Studio plugin. It is already available. You can download it. It's online. And basically, you can keep the same tools and the same habits you have, because we want to keep the original Android Studio flow. Because we know you are familiar with it, and this is something that we really wanted. We didn't want to change it. So what we did is merely adding tools to the existing environment, tools for robots. Basically, doing your application is exactly the same way. But we also provide APIs, so that of course you can make the robot move, you can make it talk, you can make it interact, which is what you would expect from an SDK, but more like interesting tools such as animations. So you can use pre-existing animations that we provide with the SDK, and you can also create your own. We will get to that later. And we also provide a chat editor so that you can script very simple interactions with the robot, which is voice commanded. And last but not least, the SDK also provide a simulated robot, so that even if you don't have a robot, which is probably already the case, you can already start developing your own robotics applications. And for the rest, it's the same. So once your application is ready, you can create your PKG as usual, and maybe even publish them on the Play Store. So, pass the slide. We don't have so many slides today because what I really want to show you is the SDK itself. So on the left side, you already know this, it's Android Studio. And in the upper right corner, you see Android emulator. And the last item is the robot view. So the robot view is basically a simulated paper. And if you install the plugin for Android Studio, which would look something like this, automatically you will have new features added to Android Studio to be used with Pepper, such as you will notice that there are new buttons on the second line of the toolbar here. So the first one is just to manage the SDK because you can update them, normal things. And the second one is to, as I said, oops. It's OK, I can restart it. To start the emulator, which will automatically start the tablet emulator, but also the simulated robot. So we have to wait a little bit. And I said earlier that we support animation and also chat files. And these are accessible as normal Android resources using this little menu. So all the tools we are providing are there. And so you can create a robot application. You can have an animation timeline, which I will show you a little bit later. You can create chat topics or chat files, and also import animations, because we already provide a library with very nice and useful animations. So maybe you can start with a little coding. Because what we wanted to do also is not to provide the same usual way APIs work, with service and modules. Our design is based on actions. So what is an action? An action is more like a task that you can start and stop. And it really corresponds to something the robot is doing. So for instance, a window draws widgets, and a robot would perform actions. So when you create a task, you can set some parameters and then execute the task. And of course, you can do it synchronously or asynchronously, which is very important for Android. And getting called back when the action is finished, things like that. So if I take a very simple example, which would be like to make the robot say something, it would look like creating a say object. And then simply run it with the parameter. So for instance, this wouldn't be hello world, but hello IO. Now, I don't want to spend so much time compiling and deploying, so we have already pre-installed the sample on the robot. So what you see on the screen would exactly do this.
Hello, IO.
Very simple. And the robot talks. So I said that we provide more tools because writing an application is not only about writing code for robots. You have to care about a lot of other things, such as using the hardware, because we have so many motors that you really want the robot to do something. This is why we also have animations. And our SDK allows you to use pre-existing animations that our company is doing. So we provide several categories. Let's say, for instance, action, animals, because it will come back later in the presentation. Let's say a gorilla animation. So this animation, you can see the preview. You can exactly take it and import it into your project just as any normal Android resource. Let me show you. So we're happy with this animation. We select it. And this is automatically imported into the resources. You will see that the code window has changed to look like you are probably familiar with that. This is more like a keyframe setup, because you can edit those animations from the plugin. So if we look quickly, here we have the values of the joints, so you know, like the different motors, and we have the positions for the shoulders. And so we can change it, and sometimes it's not enough to just set the angles, because I could make like very, jerky animations. So we also provide a more advanced mode for the people who really want to fine-tune their animations, which look like this. So basically, it's a nice way to set all the tangents of the animations and to control how the movement would, how you would get from position A to position B. So if I preview the animation on the emulator, you see the robot, doing something. And what I didn't mention earlier is you can also connect directly to a physical robot. It's just the same. So if I preview the animation, let's say I want to change the position of like the elbow roll, and you will see like the difference instantly. Well, it's not so obvious, but you can see that the right arm of the robot is moving like in a different way. So all this can be like easily changed and customized, and this is basically how we write the densities that you've seen at the beginning, which is more a professional way of doing animations. But again, if you just want to have an application with a robot doing the gorilla, you just use the pre-existing animations. Let me show you a couple other ones. So maybe animals are not so interesting, but when you write applications and you want to have interaction with the user, you want to use expressions like affirmation or exclamation, and the robot's so happy. You can have like more complicated stuff like emotions. So if you look at positive, like blowing kisses, because it's a nice application. Yeah, so this is it for animations, and again, this is like very important when you write a robotic application, because you don't want only to display things on a tablet. You also want to have a robot that moves and that can do like a lot more things than just a normal device. Then it's also nice if you can talk with your robot. So we've seen that yesterday during the keynote. Vocal command is so important and interesting. So we also provide a way to write your own sequence, like script little interactions with the robot that we call chat files. So I have a chat files already prepared here. Oh. So I will not go into the details of the grammar, but basically you can write questions, and depending on the answer to that question, react differently. And I will show you that on the emulator, which I also pre-installed the application. And let's say you're working on a plane or in the train or whatever, and you just want to test what you're doing. We provide the dialog view. So here you can type anything and directly discuss with your robot. This is exactly the same thing that would happen if you talk to it. It's just you are feeding the text through the emulator. So for instance, hi, do you like comics? Yes. Whose side are you on? Steve Rogers or Tony Stark? That's Steve. And the robot is trolling me. So this quick example shows you that it's very easy to write your own sequences, and it can be very easy like this, but you can quickly get to more complicated examples and also have reactions tied to that. So, like starting things and all, which is more interesting than just, talking. So all those tools, again, are directly integrated into Android Studio. You don't have to do anything else, just installing the plugin and using them. So I showed the things separately. Let's look at a more complicated example, but I don't really want to spoil what it will do, so let's first start with the application, which is already on the robot, and then I will show you how it's written. Demo.io.
This is my waving animation. Watch me move and speak at the same time.
Let's show it again.
This is my waving animation.
Starting an animation, making the robot talk.
Watch me move and speak at the same time.
Then let's make it move, and hopefully not fall.
Elephant
Touch
joke.
the screen. And you have the first robotics, elephant robotics joke ever. So all this, which already looks pretty cool, I'm sure you really want to try it and show it to people, or you already have more complex ideas. I want to show you the code because it's not so complicated. Here. So I will not go into more details about the onCreate. We create the activity, and we create also a different thread because for a few statements you will see I want to block, and we don't want to stop the UI thread. So create a new thread, and you can see that there is a start method, which is just underneath, which we'll call the wave method and the move method. Let's look at the code of those. So for the wave, the robot was saying, this is my waving animation, and then waving. So 2 lines to make the robot talk. You create the say action, and then you just run it with appropriate parameters. And then the animation. What we did first was actually to import the animation, the elephant animation, into the resource of the project. And once it's done, we can just start the animation using run. So yeah, maybe more details. You can see the line with hello animation. I create an animation from the resource, hello A001. And then I can just run the animate with the hello animation. So if you want to start a different animation, we just need to make another animation from resources and just play it. Now to get the robot move, it's a bit more complicated, but hopefully we'll provide better wrappers soon. Still a bit low level. What is important is that the robot is in a 3D world. The robot is moving, and you are also moving, so you need to get a good sense of where you are and where you go, or where things are. This is why we have what we call frames. So you have the robot frame, which basically is where the robot is, and then you also have to define where you want to go. So that's why you can see the few lines of math to get the moving correct. But again, hopefully we want to make it simpler soon. So we will just set everything we want to do and set the target frame, and simply create a goTo object here, and then run it. And the robot would move 1 meter, so roughly. And then, I don't know if you remember, but I touched the screen and it played the elephant animation and played sound. So this is basically we have a callback, when I touch the picture. And so you're probably already familiar with the audio manager to just get the sound and play it. And the animation, again, is always the same thing. You just create the animation from the resources, and then you just play it. So that's it. Like in a very few lines, if you remove all the boilerplate code, you can start doing things that are very interesting. And you don't even need to know a lot about the robot itself. You just use the APIs because this is what we want you to do. We want to abstract everything on the robot side because it's a very complex thing. It's not on your display, it's like there are many things to synchronize and resources. We don't want to have confliction, these kind of things, and this is basically our job to give you the right API so that you don't have to care about these kind of things. So yeah, I think it's about like 70 lines or something, and we have a pretty good animation. So this is just an example to show you about the SDK, but I think it's not like very interesting, and it doesn't give you like good idea, not very good ideas, but we have better things to show you that we've been working on, and we've prepared 2 very interesting demos with Google, using Google technologies, and we want to show you those. And as Pepper would say, it's better with the robot. So we'll use the physical robot instead of the emulator. Want to come back?
Thanks, Roland. So today we are going to show that 2 another demos. So first one is showing the magic hand. We call the magic hand. So it's kind of the gesture recognition. So most of the devices in the mobile one, that is still using that 2D dimensional display. So biggest difference between the mobile devices and this kind of robot, that this can be expressed at any reaction by using the 3-dimensional things. So that would be one of the impressive innovation for us. So the other one is we are going to show that the telepresence today. Then, so Roland, can you show us that first one for the magic hand?
Yes. So we built a demo using TensorFlow that you're probably familiar with, and we wanted to use the We wanted to use the 3D sensor.
Starting enchantment.
So we have 2 3D
Please
cameras
wait.
Here.
Let's see.
And the robot
Let's
can
see.
get a good sense of his
Please
environment
wait.
and detect obstacles.
Let's see.
And a more
Just
cool
a
example
second.
would be what you
I
will
found
see.
it.
So this is not really a game, but it's more like a proof of concept using TensorFlow
I found
and
this
the 3D
magic
camera.
book. It sure looks
The
mystical.
idea is to detect
Would
what
you like to
my
learn
hand,
some
like the
spells?
shape of my hand. What
For the
gesture I'm
magic
doing.
signs to work, you need to first put me under your control using the spell starter sign. The magic book says to hold up your right hand towards me just like on my chest display. Hold it for 3 seconds.
So the robot wants me to do this for a few seconds so that it's enchanted. So I can take control of the robot. Okay. Doesn't see me.
Make sure you're using your right hand and holding it in front of you.
Hello. So it's supposed to see my hand and detect the shape, but so
Whoa, it worked. The magic must be strong in you.
think
Let's see if you can cast some higher level signs.
I think the robot should
Next,
be
try
blindfolded
tilting
by
your
the
hand to the
behind.
right, like this.
So the robots now want me to do something like this. So
Make sure you're using your right hand and holding it in front of you. You did it. Now try the same sign but to the opposite side.
Like this.
Make sure you're using your right hand and holding it in front of you. Amazing. Maybe you should fix the tower in
we have some
Italy if
issues
you
with
have
3
time.
sensors in this environment, but
Wow,
you get the
you're
idea.
a very talented
Stop it.
wizard.
Thank you.
I haven't seen hands this magic since the last time I visited my Masums. Let's see if you can master some other magic signs. First, put me under your spell again with the spell starter sign.
Go on. So, this is a very interesting example because, with like very few things, using TensorFlow and some learning, you can have a very interesting product with applications in real life. Because if we have this, then we can easily have things like Pepper understanding sign languages, for instance. And maybe someday, because right now it's probably a bit difficult for him, but we could also have the robot talking back. So we would support a different class of languages and translations, which would be, I think, pretty cool. So yeah, this is using TensorFlow, and we also have another very interesting example using other technologies. So I will show you.
Starting a Pepper Trio dance. Please wait. Let's see. Just a second.
Wrong application.
I found it.
It's the dance.
Starting Pepper telepresence.
This is good.
So there's something the trouble then. so next demo is a telepresence. Then you may have already having that cardboard this time. We are going to use the cardboard demo with the Peppers. Pepper has the video and also that another bunch of sensor in that robot. Then we are using that video and also the mic, and also sending to those data to the mobile devices. You can see that everything through the cardboard by using the mobile devices and the cardboard. Then if you are putting to that paper to your house, then you can remotely seeing to that so status of your house and everything. So through their mobile networks. So
here we go. So we are using cardboard, and I'm basically taking control of the head of the robot. So it's not a really nice environment, but what would be great is actually that when I'm speaking, the sound also comes out from the microphones. So I could be looking at Thomas and talking with my cool cardboard. So this is a very interesting telepresence use case because now I feel like I'm the robot, which is a bit weird. And this is also this is a very simple application. We're just using Google technologies and simply putting things together, getting the cameras of the robot, and just using normal cardboard development.
okay, thank you. So this is quite new, and then we just done just before the I/O. Then sorry for that some of the trouble. Then so hopefully you guys do making the more cool application, and then go through the Google Play, then uploading to the Google Play. So that would be created another ecosystem in the world. So you can Pepper will assist your life and settle your life, of course. Then that can be given the more opportunity to the people to be using these devices in the kiosk devices, and also any assistant for that accessibility kind of devices. That would be great innovation to this area. So thank you for joining to this session, and I hope you to the making the application, starting to the application sometime soon, and ready to that Google Play. So thank you very much.